Okay, guys, in this video, we are going to review the difference between observational study and a designed experiment and when we can claim causation. Now, this specific question that I have here is not going to be discussed because I want you to practice more and figure it out by yourselves, but I will give you just another similar example. So let's suppose again that you have an apple garden. So you have an apple garden and you want to know if a new fertilizer works better than the old. So does new fertilizer work better than the old? So you divide your garden and you decide, okay, this tree gets this new fertilizer, this other tree gets the old one, right? So you assign some trees, maybe at random, to new fertilizer and some trees too old. Okay, and then you measure the yield. Then you measure the yield. Now, question: is this an observational study or designed experiment? So every time you should ask yourself, if you're deciding whether it's an observational study or design experiment, is what about the subjects of the study? Do they have a say on which method is used on them, or they don't? If they have a say, basically they decided and you just observed them, that would be an observational study. But if there was no choice for the subjects, you just told them, okay, you're going to get the new fertilizer, you're going to get the old fertilizer, and they can't decide that, that's a designed experiment. So this is a typical example. This is a designed experiment because subjects or individuals or whatever, because subjects did not have a choice in the treatment, right? So you had to use this tree. It's not like this tree said, okay, please give me the new fertilizer. No, the tree didn't have a choice. You decide, okay? So because this is a design experiment, we can claim causation. So what does that mean, causation? It means if you did observe that there is more yield for the trees that used new fertilizer, you would say, okay, well, it's a design experiment, so I can say that the new fertilizer caused larger yield. And so that's good, right? Because it's very powerful that you were able to do a scientific experiment and actually figure out whether the new fertilizer works or not. Okay, so we can claim causation if we see it, obviously. If we don't see much of a difference, then, take it from there. Okay, so that's number one. So that would be number one. Now, number two could be something like this. So you observe that trees that are located in a sunnier part of your garden get more apples. So you tell yourself, okay, well, it looks like this part of my garden gets more sun, and that's why there are more apples. Now, the problem with that is that this is an observational study. This is an observational study. Because you are just observing what happened, but you are not controlling which tree gets which amount of sunlight, right? You're not saying, okay, well, I'm going to move this tree over here and that tree over there. And so that's not what you're doing. You're just observing and saying, okay, well, this looks like there's more, but that's probably because of the sun, because that has larger sun. However, we cannot claim causation in an observational study. So why not? Why can't we say, well, because of more sunlight, I got a bigger yield? Well, because you were just observing what happened, and there could be other variables potentially influencing the yield. It might not be the sun, it might be something else. For example, maybe the part of the garden that you think is sunnier also has better soil. And the quality of the soil is because, okay, because you get bigger yield. And it could be a ton of different factors. Maybe that part of the garden also more moist. I don't know, because of some underground stuff that's going on or whatever. So there could be so many different variables that can affect yield that you cannot claim that just because this is sunny or it looks like that to you, because you're just observing it, you really cannot claim causation. That's the problem.